Hey everybody, Lars here. Figured I'd get online tonight and do the second review video for Unit 2, which is a pretty important one. It's on loops and iteration. This is the one where after we get this done and under your belt, you're really going to be able to move forward and do more programs that get things done and more interesting things. So this is a pretty important spot. I always like it when we get to this spot and we get past this hump, this bump in the road. Because once we're past this, then all of a sudden the programs get interesting. And as you'll see, even tonight, we're going to do something semi-useful. So you'll definitely see a difference as far as your programs having a little bit more meaning. But let's get started. I don't want to take forever. Hopefully this won't take super long. And then we can real quick get to the announcements. I apologize for my voice and my seemingly mopey cadence. I am sick as a dog. It's not so bad. I can't do this video, though, so don't feel too bad. But I don't know what it was. I think last week my clutch in my Jeep went out. So I was without a car for like 3-4 days. So I had to get up, trudge down to the train station, take the train into Rutgers, la la la. I know, boo-hoo-hoo. I'm not complaining. I'm just saying I was run rampant for like 3 days last week, and I didn't know what was going on. I think it just wore me down, and then I ended up getting a cold, so it sucks. I'm all chock full of acetaminophen right now, so we'll see if that can do anything. But forget about that. Plus, I couldn't slow down yesterday. It was a Super Bowl. What am I going to do, miss the Super Bowl? Not in this lifetime. So, and it was a good game, great game, and Denver won, so I was kind of happy. I was rooting for Denver, so. Well, it was a good weekend, but then all of a sudden I'm sick as a dog. I didn't go to work today. I just went to the grocery store. I was sitting in the grocery store and I'm saying I better have fun food shopping because I think it's the most fun I'm going to have all day. Isn't that terrible? How boring is that? It is boring. They will never. I couldn't be cooped up. I'm never going to let them catch me alive. Let's put it that way. All right, enough of this garbage. Let's go and do some Python. I think, yes, I do. I set up a test program, so I have this. All right. I'm going to put some comments. I'm just going to put author Lars, and I'm going to say loops. Now, what am I going to do first? I'm going to show you a very simple loop over a list to prove a point. I will call this the list, and I will make it equal to some even numbers. Oh, I did not want to open with a brace. I want to open with a brackets. There is a difference. Be wary of that. So now I have a list. We'll just prove that point. And as you can see down here, it just prints the list in brackets. I have a list of 5 items. I'm ready to go. Now, what if I want to do something with every item in that list? Okay? I want to jump into what we call a construct or a programming situation where I examine every one of those items in that list and perform the same task on every one. So I'm going to create what's called a loop. And in this instance, I'm going to use a for loop. So I say for, and then I usually say I. Some people say I stands for index. Some people say iterate. I think it hails from mathematics. It doesn't really matter. Usually convention is when you use loops, you start with I, then you go to J, then you go to K. You'll see nested loops later. We'll do all that. But for the time being, we're just going to use I. So I say for I in, and then I just say the list, colon, indent for, and then type a command that will be run for every item in that list. Okay? The reason I do this first is because this is the way Python does loops. Python iterates over lists, and that's really the only way it does iteration. In other languages, you could set up for loops where you set up a condition where the loop stops and then you start a countdown. You say increment by 1 and keep going until this happens. Okay, so it keeps counting and counting and counting. Python's a little different. It just does lists, and we're going to see in a second that we could still do for loops the old-fashioned way. It's just we have to create a list of numbers, that's all. So it's kind of a more common sense approach to iteration, if you ask me. But anyway, just to finish this out, let's say I just print I. So it prints every one. And then at the end, just so you see something that is done once, I will do the end. Okay. F5, as you can see, printed 2, printed 4, printed 6, printed 8, and it just printed it out. Now, you know from your slides that all we really do when we do iteration is show lists of numbers. That's not the point. The point is to show that you can do something every time around. So let's do that. Let's square it. See, 2, 4, 4, 16, 6, 36. As you can see, we square things. Now, it just doesn't have to be one command. It could be a block of commands. So I'm going to print the number, then it's square, then it's cube underneath it. So if I run this, you can see that right there. 2, 4, 8, 4 cubed is 64, 6 cubed, 216 on down the line. See? So you're not just having to run one command. You could run a whole block and do whatever you want with that. Okay? As per usual, I will put this code up in Sakai when we are done with it. Now, the next thing I want to show you is pretty important because it's the way most of the loops are done in Python, is to create a range of numbers and then iterate over that number. If you just wanted a simple for loop to do something 10 times, I would say for I in range 10 that, and I would print I. Let's see what this gives us. All right, that gives us from 0 to 9. Remember, we are computer scientists, and we start counting at 0. But why did it give me 0 to 9 and I said 10? Well, the reason is this. That 10 sitting in there is really shorthand for this. And I'll explain it in a second. You see those three things, 0, 10, 1? Watch what happens when I run it again. It's the same thing. This is what range is. Range is starting point, exclusive end, the first thing you don't want. It's Python. It's just like slicing strings. It's a range. So you ask for the first thing you don't want, and then what's called your increment. How much should I go up before I do it again? So as you can see here, start at 0. 10 is the first thing I don't want. Go up by 1. So that's why you get 0 all the way up to 9. If I said go up to 21, start at 0, go up to 21, but increment by 2, well, look what you get. 0, 2, 4, 6, just like that, see? Now, something interesting about this is that, let's try this. Should I do 10, 11? Is it 11? No, I don't think it's backwards. Let's... We can go backwards. You have to tell it you want to go backwards. You give it the start. Let's say we'll make this 10. You give it the start, 10. You give it the end, 0, which, as you can see, because it printed a 1, is the first thing you don't want still. And then you say -1, so that you go backwards. Let me try that again. Okay, see? Classic countdown. 10, 9, 8, 7, all right? So that's how range works. All right. If you want to use a little bit of range shorthand, you can just give it 10. It'll start at 0 and increment by 1 as a default. So 10 is the first thing you don't want. That is going to give you 0 through 9, as you can see right over there. Okay. So I'm going to leave that. Actually, you know what I'm going to leave for you? I'm going to leave 0, comma 1 like that, so you're reminded. But the default is just 10. Okay. Now, I think I want to do something fun. I am itching for some fun. As I said, the most fun thing I had today was going to the supermarket. My supermarket that I went to since I was 9 years old shut down 2 months ago. So I have to go to this new Stop and Shop on Route 1, and I don't know where anything is. It takes me hours and hours to go food shopping because I don't know where anything is in that stuff. I'm like Rain Man. Hot water burn baby. I just sit there and it's stunned, like I was hit over the head with a club or something. It's amazing how dopey I am when it comes to simple things like food shopping. All right. Now, I've got loops under my belt. I got lists under my belt. I know how to do a few things with Python programming. So why don't we start going into the world of solving some problems? Let's say with the numbers 1 to 200, find the squares greater than 5,000. All right, you know what? I'm just going to do 100 because I don't want to get into this. All right, there's a real problem. Kind of a contrived little mathy problem, but that's a real problem anyway. With the numbers 1 to 100, find the squares of those numbers that are greater than 5,000. All right, what are we going to do? Well, I could do this. For I in range, I'm going to start at 1 because I don't want 0. I want to go to 101 because 101 is the first thing I don't want. I am going to increment 1. I'm going to print I, but I'm going to square it. So then I run this. All right, look at that. Those are the squares, yeah? Think so. 4, 9, 16, 25, 36, 49. Okay, these are the squares from 1 to 100. And then I guess, yep, I got 10,000 at the end, so that makes me happy. All right, so I already have the squares. Now I just need to know what's higher than 5,000. I do, yeah, I have a lot higher than 5,000. All right. What I think I'm going to do, though, is I'm going to put them in a list. Remember what I was screaming and yelling about before? Lists are like bookcases waiting to be used. So I am going to, hold on, move that chair again. I'm going to create a list. I'll call it squares. Yes, I know. And I'm just going to give it 2 brackets like that, which creates a blank list for me. And then down here, I'm going to say squares dot append, and I will add the squares. So now print squares. What do we got? What do we got? Nice. So created a blank list. Then I iterated over 1 to 100, and I squared the number and put it in the list. So now I have a list of all of the squares from 1 to 100, which is pretty sweet. Because what I'm going to do next is this. I'm going to say for I can use I again because that loop is over, in squares. Remember the first thing we did? We're just iterating over a list. We don't have to set up a range every time. I have my list of squares. I don't need anything else, so I'm just going over squares right now. What do I want to do? What I want to do is I want to see if something is greater than 500. Wink, wink, nod, nod. We just did this. If I is greater than 5,000. All right. Now, here is the issue. I know that whatever I'm looking at is greater than 5,000 because it dropped into this loop, but what do I want to do with it? So at the end of the day, it just says find the squares. So that could mean just, stick them in a list. So maybe we stick them in a list. When I see find the squares, I also think that I might want to count them. So in this situation, how would I count them? What would I do? What I might want to do is I know I'm starting a little loop in here for I in square. So every square I'm going to look at, when I find one greater than 5,000, what would I want to do? I'd probably want to have like a clicker that I can just click off one. Yeah, that's greater than 5,000, click. Yeah, that's greater, click. Yeah, that's greater, click, boom, and just keep going. So how would I do that? The way I would do that is I would create a variable called a counter. Before we go into the loop, I'm going to say count equals 0. So I have a blank counter. And I'm going to show you, I'm going to tell you why in a second. Because I'm going to say count equals count plus 1. So I'm going to add 1 to this variable, but I want to maintain what it is. So that's why I say count plus 1. If you remember way back to the beginning of the course, when I said that equations are evaluated from right to left. If I get this evaluated and there's no variable count that exists, the program will go, whoa, there's no such thing as count, and it'll blow up. So what I did is I created something. I gave it the variable count, the value 0. So the first time through, when it sees count plus 1, it says, oh, okay, count exists at 0 plus 1. And then count is equal to 1. Then the next time through, count will be 1. 1 plus 1 is 2. The next time through, 1 plus 2 is 3, and so on. Every time as we iterate through this list, there's a value greater than 5,000. We're going to click, is the term, click that counter. So that when we get to the end here and we drop out of this loop, do I have anything down here? No, I don't. I'm going to say print. There were misspelling, who cares? Count squares greater than, I can use the whole thing, 5,000. Alright, let's see what this does. Alright, there were 30 squares greater than 5,000, and I believe that is correct. If we wanted to, we could print them. We'll just say print I, and then that would print them all. And then you would see 30 squares. If you want to know which one is which, I could print them and then say dash 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 point count. So the first one's going to be 0. Let me do count plus 1. I don't think that might work. And as you can see, it counts them all the way down the line. And you can see that there are 30 of them because we have them enumerated now. And you can see that there are 30 greater than 5,000. Okay. Boy, this is simple. There's no, great shakes going here down here. There's no brain surgery. What is that? 10 lines of code. But look what we're doing already. Okay. This was a real problem. We took the squares from 1 to 100 and we found out how many of them are greater than 5,000. That's, trivial in a sense, but we're learning. We're doing something. We transformed our numbers into something that we wanted to examine, and then we examined it. And as we examined it, we not only removed them or, printed them out from the list, we also clicked off how many of them there were. Now, there's one last thing I want to show you that goes hand in glove with counting, and that is adding things up. Now, we're going to learn some easier tricks later, but for now, I'm going to set up a new variable called a cum, okay? And what I'm going to do is after I click my counter, I'm now going to add something to the accum or the accumulator. Now, I don't want to add 1 to it because the counter's doing that and we're counting things up. If I want to accumulate all of these values, what would I add? The number itself. So the number itself is I. So, I will cut and then I will paste. Hopefully. Yay. There were count squares greater than 5,000. The sum of, oh, that was a mess. Print. The sum of, now we delete, is squares greater than 5,000 was colon, comma, cum. And there you go. So now you count all of them. You grabbed all of the squares. You rip out the 30 of them that are greater than 5,000. You found out there were 30, and then now you've added them together. So now you have their sum. Okay, all in these few lines. Now you can see some of the things about programming that make it, good for solving problems. This is an even better thing. Watch. What if I ran this code only instead of 101, it's 1001. Same algorithm. Still works. Only now we have a lot more numbers, and of course the squares are going to be greater than 5,000, but look. And believe me, it runs faster than that. What was slowing us up was the printing. Watch. Let's just get rid of that. We'll comment out that print statement and see how fast it runs. Bloop. See, it's the printing that was slowing us up. It was not the calculations. Computers can go pretty quick. My little Alienware right here has an i7 processor and gobs of RAM. So performance, especially for simple Python programs, is not an issue. As you can see, we just made short work of that right there. Boom, boom. Okay, so real quick, we now have lists. We now have iteration. We just did something interesting. We created a group of numbers we wanted to take a look at. We examined them. We counted them up. We accumulated them. We did some different things. Remember using counters and accumulators because you'll use them a lot going forward. One thing you should know, you don't have to use these variable names, okay? These variables are given their names because of their function, not because they have to say accum or count. If I wanted to, I could knock them down and just call them A and C. All right? So we'll do it right there real quick. And as you can see, everything runs fine, same results, everything is good. The variable names have nothing to do with it. It's the function those variables perform. The fact that they are counting and or accumulating those values, all right? Remember, this code is here. It's not going anywhere. This is YouTube. You can always pause it and go back and look at how we did things, so don't worry about it. All right? What do we want to do now? I think we really only have three things we want to take a look at. One thing that I'm going to go over really quick for I in range. Let's say 3, something simple. Print outer, you'll get this in a second. For J in range 4. Print inner. What kind of insanity is this? This is what's called a nested loop. You can run loops inside of loops. You can see here I start the big outer loop, and it's only going to go through 3 times. Then I just print outer, so we should see outer 3 times. There's 1, there's 2, and there's 3, so I'm good with that. Then, I'll put this over here. Inside that outer loop, I run another loop. I call the variable j, because I go ijk. I call it j, and for 4 times, I'm going to print inner. So it says outer, 1, 2, 3, 4. Good. Outer, 1, 2, 3, 4. Outer, 1, 2, 3, 4. So that's an example of what we call a nested loop. Now, you may be saying, hey, that's really neat, but who really cares? The reason you're going to care is because this is going to be the way you are going to traverse data. Traverse is like go across or consider all things in something. When you need to traverse something that's in a grid with rows and columns, this is the way you're going to do it. So your outer loop is going to be the row, and your inner loop is going to be the columns, and you're going to go 1, 2, 3, 4, 5, 6, 7, and then when you have to drop down to the next row, that is an outer loop change. Then boosh 2, 1, 2, 3, 4, 5, 6, boosh. That's how you're going to examine grids when you get 2-dimensional data storage in like a square or a database table or something like that. So this is used quite a bit. I wanted you to see it, all right? Be wary because this is something that could show up on a test, all right? But you have it in your slides. You've seen it here now in a review video, so you should be ready to rock and roll when you see something like that. All right, let's move on to, I think I want to do something. Oh, let me save that. Something right now called a while loop. You've seen that we have done iteration over a list. So I usually know how big my list is. Sometimes you don't, though. But I know I have a list of 100 items, or I have a list of 500 items. So when I iterate through that list, I know I'm going to do 500 iterations. When we solved our problem with the squares, I knew I had 100 squares in there. So I kind of knew how long my loop had to be to get the job done. But there are instances where we don't know how long we want to be in a loop. I mean, if we know how long, if we're doing it 100 times, if we're doing it 50 times, that's called a definite loop. If we don't know, we call that an indefinite loop. And one of the examples of an indefinite loop is usually, well, I'll explain it at the end, but it usually runs in a form of something like this. You have like a simple character that you look for, and then you say while that variable is not no, go into the loop, and I will print in loop, and then I will say char equals input enter, or I'll just say still loop question mark, and that's it. So hold on, I'm going to explain to you what it's doing. All right, get in there. What I'm doing right here is I'm setting a variable called CHR, which is the beginning of character. I just call char. That actually would be a bad thing in other languages because it might be a keyword somewhere else. So, but anyway, I say char and I make it equal to y, single character. Then in my while loop, you see it's orange. Idle has made it, colored it because it's a keyword. I say while char. Now remember, there's nothing wrong with doing this if you want to do this. Other languages you need to bracket your control stuff or your decisions, but you don't have to in Python. I usually don't do it just to show it as an example. But while character is not equal to n, it isn't, it's y. Run this loop. So I drop into the loop, I print in loop, and then I ask, hey, do you still want a loop? Now, we'll see when I run it. If I give it a y, then I come up here, while char not equal to n, still true. So I do in loop, and then I ask again. And let's see it run. Okay, in loop, still loop, yes. Still loop, yes. Still loop, yes. Still loop, yes. Now, it says still loop, I'm going to say n, and it's going to drop me out. Okay? Now, that was an indefinite loop because, watch, if I keep saying yes, it's going to loop. It's going to keep going and keep going and keep going until I give it that n, and then it's going to drop me out. This is useful usually in video game context or in game context where you still want to play the game. Do you want to do another calculation? You can put your whole program in one big while loop, and then at the end just ask a question. Hey, you want to stay here? And you look at that one character. Sometimes we call it a flag, and it can pop you right out. One thing that's kind of funny about this, I've done this before, is you see I'm giving it the y. Well, I don't do any error checking. So frankly, I can give it anything I want, and it's not going to throw me out of the loop. There's only one thing that's going to throw me out of the loop, and that's the n. And the n is always going to throw me out of the loop. Because at the end of the day, I'm asking for, not equal to n, not equal to y. I could say while char, I could do this, and say while char equal to y. Maybe I should use 2 for equivalency and not worry about assignment. Okay, still in loop, yes. Still in loop, yes. Still in loop, yes. Now when I give it to no, boom, it drops me out. But this time it did it because it's not equal to y. So either way, you can go. Actually, the way we just did it is probably better because I can keep giving it y's, but now if I give it an a, it'll drop out because it's not a y. But I didn't explicitly give it an n, so we will leave that as an assignment for the advanced student. All right, so that is actually 2 kinds of loops. The first kind of loop is that it's indefinite. You don't know how long you're going to be in there. And while loops are good for things where conditions change in the loop and you want to test that condition every time before you go into it. It can be something like this. It could be other things as well. Another kind of loop that this is called an interactive loop. So you're taking input from the user while you're doing the looping. So because of that, it's interactive. The user basically is controlling how long you stay in the loop. So that's an interesting point about that too. All right. So we have while loops under our belt. We have definite, indefinite loops. We have interactive loops. We know about range. We know we only iterate over lists. If I'm not mistaken, there is just one last thing that we have to go over. And that is something that might have something to do with a homework assignment you got tonight. Tonight being February 8th, the day after the Super Bowl. We're going to look at something called a Sentinel Loop. Matter of fact, I'll even put it here like this. Sentinel Loop. Look at that. I'm going to create a list. I'm going to call it my list. My list equals 2, 3, 1, 45, 54. It does not matter. I will even throw in some negatives for giggles. And then I will throw in, now let's do 200. Okay, so we have that list right there. All right, let's say I want to count up everything in that list. Should be a piece of cake with our new tools. For I in my list, what do I want to do? Well, I want to accumulate them. So let's come up here and set an accumulator variable to 0. And then let's say accum equals accum plus I. And after we have run through everything, we will print the sum of the values in, yes, because I can't spell, my list is cum. Yay. I have no earthly idea if that is correct. I'm hoping it is, and I'm guessing it is. All right. So that was easy because we regarded the entire list. But what if I said to you, give me the accumulation of everything in that list up to 200? All right? So now when I come in here, I go through the entire list right to the end. There's no stopping in the middle. I could probably use a range and count how many items I have before 200, but we really don't want to do that. That's sort of a fudge. When we solve problems and when we learn computer programming, we want a code for general solutions. So if I gave you a list with 300 numbers in it, and let's say 200 was the 248th number, our solution should work on that list as well as this list we have right here too. So we want to find a general solution to this problem. So what can we really do? What I'm thinking is we can do this. For I in my list, I'm going to say if I is equal to 200, no, I don't want to say equal to. I say if it's not equal to 200, then I accumulate it. Else, so what does else mean in this instance? Else means it's 200. Because here I said if I not equal to 200, we'll come down and do this. If it is equal to 200, then we do the else. So I'm going through my list. If it's not 200, I accumulate it. But when I hit 200, what do? I use the command called break. Now break drops you out of a loop. The minute you see the break, it just says, all right, I'm out of here, out of Dodge. So by using break in this construct right here, what I'm doing is I'm going along, accumulating the numbers until I get to that 200. And when I get to that 200, I get out. Okay, so the sum of the values in my list before 200 is, now, what should this be? Let's say 2 and 3, that's 6, that's 51. I'm not going to be able to do this. 105, 139, that is 180, 93, 23 from 45. So add another 23 to it. It's going to be 220 something. I don't know. We'll see what my math does to me. Okay, 215. I hope that's right. I bet you that is right. Well, you know what? There's one way to test to see if it's right. And I'll do it in a second. So As you can see, we just added the numbers to our accumulator until we saw 200. And when we saw 200, we went to the else and we broke, and then we printed things out. Now, the sum of the values in my list before 200 is 215. How do I tell if that's correct or not? Get rid of values. Get rid of everything. All right, now we have a regular loop. So now if we just get rid of our construct and we go back to the way we were, were you waiting for a Barbra Streisand joke? I couldn't think of one that quick, so you didn't get one. All right, it was 215 because now I just set it up regular. And we did that. Okay? So that is a Sentinel loop. No worries. I'm going to go put it back the way it was. As a matter of fact, I'm going to do it for you right now. There's 200, and it really doesn't matter what gunk is over here after that. So what did I do? I said, if I not equal to 200, no, I want to indent after that. So I should see that. And then I say else. And then I say break. And then when I run, I still get 215. I do. So I know I'm back in business. I'm going to leave that for you because, like I said, I'm going to put this code up on the web. And you're going to be good to go. All right? Okay, I'm getting rid of this. Well, let's see what this gives us. If I come up here and I get rid of this. And I get rid of this, and I run the thing. Look at that. All right, we got everything. I'm going to take this and I'm going to throw it in Sakai for us, so you got no worries as far as that's concerned. Okay? That's it. You have loops now. Remember, in Python, we iterate over lists. That's what we do. When we want a definite loop and we know we want to do something 20 times, 30 times, we use the range function to create lists of numbers, and then we iterate over those lists of numbers, okay? We now can do useful things. We have lists, we have bookcases in which to put things, and we can loop through lists and find interesting things about them. Here, we found the squares for the first 100 numbers, but then we changed it to 1,000 later. We could even do 1,000,000. I bet you 1,000,000 would run pretty quick too. Well, we'll do it some other time. Where you could actually solve some interesting problems now, because you could create a list of numbers. You could take all the cubes from 1 to 100. You can take all of the squares. You can do whatever you want, and then you can go examine those numbers and base it, filter them based on certain criteria that you have. And then after you've done that filter, you can count those numbers. You can accumulate those numbers. You can use them in another loop. You can do all kinds of things, and you're going to see as we move forward. This is how we start with data science with Python. You're looking at things, you have them in a list, and then you can use that list and iterate over it and see all of those values one after one after one after one. So things are going to get powerful soon, okay? You saw nested loops. Just keep that in mind. You can run a loop inside of a loop. There's nothing no law against it or anything like that. You saw the while. The while is there because sometimes we don't know how long our loop is going to go. And we need a structure where we can do an indefinite loop and test against a condition every time through. And that's why we use the while. And the Sentinel is just, hey, keep doing something until you see something. That's all. That's all the Sentinel loop is. Keep doing something until you see something. Okay? So now we've got some okay tools in our toolbox. We're going to see that in the next video I do, because I'm going to give you a couple days to start working on assignments and finish up, read the materials and do stuff like that. But, excuse my cough, later in the week, I'm going to do my first video about Project Euler. And we're going to go grab a Project Euler problem and solve it. And we're going to solve it with lists, and we're going to solve it with iteration, and we're going to solve it with all the other things that we're learning about. And you're going to see, oh, you know what? Here, I can use this Python to solve real problems. It's not just doing little book problems or little 10-line toy problems that you get in, the Zell book or some of the other things you're looking at. We're actually going to be able to go and say, hey, if I have A, B, and C, well, what if we had this and wanted to look for this? You're going to be able to do real problems like that. And also, once we get to Project Euler, you'll see that, and you'll get a kick out of Project Euler. And you will never want for practice problems again in your entire life, all right? All right, good. That was a long one. I got to get some sleep, because I got to be up tomorrow. I actually have a Python workshop I have to do in the morning. So I have to be semi-human. I have to get up early enough that I can gobble down 5 tons of contact. So I have half the symptoms I have right now when I get in front of those poor kids. Tonight, I released the information you need for your midterm project. Go look at it. It's not hard. Most people think it's fun. You'll get a kick out of it. So now you have the instructions. You can go and start engaging with those resources, the MIT OpenCourseWare, the Learn Python the Hard Way, all the different tools that are out there to help you learn Python. You get to go through them, you get to review them, and you get to compare and contrast and say what you like about certain ways of doing things and what you like about other methods that people use to learn Python online. I released your second assignment tonight. You have 8 days to do it because all of these things will not be due until the 17th, but early in the morning the 17th, so I don't think you have the whole day. I think it's 1 a.m. on February 17th. I think that's a Wednesday. So you have some time still, but the whole reason these units are stretched out over 2 weeks is so you should be done reading all your materials now, and you should be using what you've learned with the assignments. Now you go back and reread it, obviously, and you watch these videos, and you do some other things. So this is your second coat. This is the second coat of paint, all right? Then this weekend when you're getting ready for the quiz and your assignments are already pretty much done, then you go back and consider the materials a third time. That's the finishing layer. That makes the paint job nice, shiny, and new, all right? Trust me on this. All right, so I am getting out of here because I need sleep, and the last week has been a whirlwind, but things should be fine. You're going to really like Project Euler. I promise you, you'll like Project Euler. The next video is going to be cool. You'll get a kick out of it because it's just a website where you can go get these math problems, but they're not overwhelming. They're clever math problems that you can solve with programming languages. And right now I think they're up to 500 of them, and they're interesting and they're cool, and they keep stats on them. So we'll be able to sign up and you'll be able to keep track of how many you've solved, how many you haven't, blah, blah, blah. It's a really fun concept and a really fun thing. All right. So keep chugging. Eric is doing the assignments tonight, so hopefully I'm getting emails out to you tomorrow, but I'm going to have to put my foot up against his backside if I don't start seeing assignments tonight. All right? So don't worry about it. We're on that. Everybody did well anyway, so you got no worries. Okay? So you have a good night. I'll be in touch in a couple of days. Just make sure everything's okay. As always, if you have problems, go into forums, ask questions. That's why we're here. Okay? Anytime you have a problem, you can go to the cave as well. You know that. Shoot me an email. We're all in this together. All right? I don't want anybody worried that they don't understand something or how do I do this, how do I do that. No. Come to the cave. Ask questions. Now's the time. All right? So we can nip those problems at the bud and move forward. Because this isn't hard stuff. This isn't hard stuff. It's just taught incorrectly by most people. There's nothing hard about it. And you're going to see that because you're all doing great. All right? So you have a good night, and I am going to get out of here and see you in a couple days, all right? Take care. Please, don't catch cold. Take care of your health. Bye-bye now.